lights are shaking in here. Let's check thermals.
So as you can see, what this video is going to be about is nulling out certain aspects of the fans, finding the weak spots, finding the balance issues, and then checking thermal.
87, 86 on the motor. 84 on the ESC. Motor 2's at 87. ESC 75, that's good.
Now this is sort of a technical video, so if you're just looking for shock and awe, you're going to have to look somewhere else. Right now we're talking about this engine, that engine, thermals, balance, so on and so forth. So if that's not something that interests you, then, you know, scroll away. Unless you're interested, stick around, because you might find this very interesting.
Wow. Okay. Never been behind this thing. Oh, pushing that air. That's a lot of air. Good Lord. Not bad for a 48-volt test. Still want that one more battery, man. I gotta get that last battery. These things are expensive. Whew. They only sell those in the pairs, and they're like 250 bucks. I need one more to make 75 volts. A 48 on a 90 angle, a 90. Well, it's well over a 90-degree bank. So that's actually a pretty good test. Everything seems to be holding together nicely so far. So far, fingers crossed, so far. You can see some slight motor mount torquing as I ramp up. So we'll remember that when we do the maiden. When we do the maiden, we won't torque it so much when we're trying to take off. Remember everyone, this is a prototype, so anything could happen. Alright, let's let it idle. For a minute, you can hear it now. That knocking, that's going to be one of these motors. That's going to be one of the motors. Hold on. All right. So this one's knocking. These set screws on that shaft give me a little bit of a concern. It's literally a 3mm set screw, but seems to be holding steady so far. Motors aren't really hot. ESCs are cool. They would be, right? Right in the middle of that. this set screw looks like it may have come loose a little bit.
Yes, I am going to be working on getting a lapel mic. Don't worry, I know what you're thinking.
Put that thing. There it is.
These are one of my main issues, are these 3mm set screws in an elongated keyway. Becomes an issue. They loosen up.
I think this is my weak point right here. All right. See it again. That's some serious air.
Now, one thing you have to consider is we are using only 48 volts, which is half the RPMs that this system is capable of. So this is balancing and testing only.
See, that one stopped later. There's some drag on this one. I think it's that roller bearing. Hold on. Where is the intervalon? Oh, it's over here. I think that roller bearing is warped a little bit. That one's still stopping a lot slower, which means that there's drag on this one. I think at a lower RPM it does vibrate a little bit here, but as it gets pulled into that tapered roller bearing, that kind of levels out. So that's what we wanted to find out, because that lets us know that there is some vibration in the motor mount. There's some slight axial misalignment, but if I loosen the set screw, spin it up, and let it seat into that roller bearing all the way, and then tighten it back down, we shouldn't have an issue. Ready to feel some wind? You feel it already? Good so far. It shows me, yeah, see, it shows me that there's a vibration at a lower RPM, which is fine. At idle speed, that's not a big deal. Whether that continues to progress closer to the 8,000 and 10,000 RPM mark after we get that last battery, that will determine whether or not it's completely dynamically balanced. But it does let me know which fans that I need to focus on. We're going to do another thermal test.
Obviously, keeping a thermal record of what's going on right now is very, very important. Helps me decide what to do next, what to replace, what to look at more closely.
102. ESCs are sitting at 84, motors are sitting at, right now, 95, 102. So those fins I put together are doing really well for cooling, and putting the ESCs where I placed them is even better. Dropping in temperature. Temperature's dropping. If I'm yelling, it's because I don't know if the mic is picking it up. ESC 82. Motor 96. Those thermals are looking sweet. And the balance, once that torque hits and pulls it up towards that roller bearing, it loses all of that vibration. Because, I mean, come on, with as big as this thing is, if you're dealing with vibration, that's not a big deal. It's not a big deal. The whole thing's 3D printed. What do you expect? But those tapered roller bearings are doing their job. All right. That one stops slower because there's still a little bit of drag on that one, but that's okay. Now what we're going to do is we're going to check thermal heat soaking. Turn on the eclipse. All right. You can see it creeping up the metal on the aluminum. 102. Staying clear. 86. 84 on the ESC. Wiring looks good. Battery 84. Wires 77. 78. That's good. That is extremely good thermals. 104 even at heat soaking. Bearings 80. 78. Wow. Might be vibrating a little bit at lower RPMs, but everything is looking good. Let me check. Well, that bearing's 113. So that one was, I was correct on the drag on that one. 122 on that bearing. Let me see if it's melting anything. It doesn't feel like 122. But, I mean, the thermals don't lie. Yeah, we got, okay. Front bearings, stabilization bearings are fine. They're at 77. This one's at 82. It got a little warm. Not enough to bother the PETG at all. Wow. This bearing's cooling down already. This is where I'm having, okay, so it's the bearing on this side. That's what's causing that drag. Just like I thought. We're just gonna have to make sure she's lubed up. So that bearing is a little off, or it's damaged in some way. The only option I have to fix that is to take the engine off and then take off the back end of the fan shaft, pull the fan out completely, and then reprint the whole shaft, and then replace that bearing. Which we could do. This is a prototype, like I said. So these are the tests that matter. But that was fun. And it definitely cleared all the dust out of here. So there's that. Alright. So unplug these ESCs. Heat soaking on the batteries. These are still cold to the touch. So the discharge rate on those is amazing. Makes it perfect. Obviously, we're not using a flight controller just yet. Okay. That was a good run. So what we're going to do now is we're going to decide what we're going to do with engine 2 on the roller bearing, and then we'll move forward from there, even if I have to pull that back out. You gotta remember, I don't want to rush this project. It's taken a very long time to get where I'm at. So I think what we're going to end up doing is we're going to finish installing the rest of the motors and check all of the bearing stability. Make sure everything's running good. Motor 1 is running excellent. Motor 2, we have a drag on that bearing. So that's one of my main issues. That's okay though. We can fix that. And we'll get the rest of these things mounted up. Test all of them at the same time. Now I was running this as S-Bus, not on the flight controller, because I needed to test. This is what I was doing, was the thermal testing and this bank angle that we're doing here, this 90 degree, well over 90 degree bank, because we do have a center stack of bearings inside of each one of the stators. So that was good. That was good. I'm happy with those results. And I've never felt the wind from that, from behind it. So that in itself was awesome. I hope you guys stick around for more, because there's a lot more to come with this baby. And there's going to be a lot more testing, a lot more building, a lot more modifications. We're getting close to a maiden. I don't know how close, but we want this thing to run tip-top for its maiden. So stick around. I hope you all enjoyed the video, and thank you for watching. If you made it this far, please like and subscribe. Share it with your friends. Share it with your family. Share it with everybody. If this is something you're into, I hope you enjoyed it. I certainly did. Thank you for all your support, and I will see you all again next time. Have a good one.